In this video, we're going to talk about how to describe reflections of linear functions. So in a family of functions, the most basic function is called the parent function. The parent function of linear functions is f of x equals x, which is a line with a slope of 1 and a y-intercept of 0, 0. So all of the linear functions are considered to be transformations of the parent function, and there are three types of transformations. The third group, which is reflections, is what we're going to be talking about today. A reflection will produce a mirror image of a graph by flipping it over a line. So you can see that g of x equals negative 2x, which is in red, is the mirror image of f of x equals 2x. So reflections will flip a linear function over a line. So when f of x is transformed to negative f of x, the graph is reflected over the x-axis. When f of x is transformed to f of negative x, the graph is reflected over the y-axis. So what happens when f of x equals 3x plus 2 is transformed to g of x equals negative f of x? So based on the way this is written, I would say that this is reflected over the x-axis. But let's look at the equations to make sure that this is true. So if I have g of x equals negative f of x, that means I'm going to take the negative of f of x, which is 3x plus 2. Remember, this negative in front is basically like a negative 1. So I'm going to distribute it to both terms. So I have negative 1 times 3x plus negative 1 times 2. So this becomes negative 3x plus negative 1 times 2, which is negative 2. The plus negative is going to become a minus, so I have negative 3x minus 2. So that is now my value of g of x. So if we graph both g of x and f of x, you can see that g of x in red is in fact this graph of f of x reflected over the x-axis. So if you think about the x-axis as being like a mirror, you can see that this is a reflection of the original function. So what happens when f of x equals 2x minus 1 is transformed to g of x equals f of negative x? So based on the equation, I would say that this is reflected over the y-axis. But let's just verify by looking at the equation. So what I'm going to do is I'm going to plug in negative x into my original function. So I have g of x equals 2 times negative x minus 1. So that basically becomes g of x equals negative 2x minus 1. So let's graph both functions to see what happens. So you can see here I have my graph of the original function in blue, and then I have my new function in green. If you think about the y-axis as a mirror, you can see that this graph in blue has been reflected over the y-axis. So let's write an equation of the function g and describe the transformation between f and g. So we have 3x minus 1 and negative f of x. So this is going to be reflecting over the x-axis. So if I write my new equation, I get g of x equals negative of 3x minus 1. I'm going to distribute like it's a negative 1. So I have negative 1 times 3x minus negative 1 times 1. So I have negative 3x minus negative 1 times 1, which is negative 1. So this becomes negative 3x, and then minus a negative will be plus. So I have negative 3x plus 1, which is g of x. So if we look at g of x and f of x, you can see that this graph is in fact reflected over the x-axis. If you think about the x-axis as being like a mirror, you can see that this graph has been reflected to create the transformed function. So in summary, here is all of the transformations that we've talked about so far.